All right, let's finish this up. So I want you all to try the last three on your own. So looking at this, the first part is cosine. Remember, the domain of cosine, just a regular cosine, is everything. So that's fine. So cosine of 135 degrees. Let me work over here. So 135 degrees puts this over here. And if this is 135 degrees, then what's left is 45 degrees. Okay? And so cosine is positive, negative, negative, positive. So this is going to be a negative answer. So this we end up with inverse cosine of cosine of 45 is square root of 2 over 2. So negative square root of 2 over 2. All right? So that's the first part. Now, whenever you're giving the answer for cosine, though, the answer has to be in quadrants 1 or 2, where quadrant 1 is your positive answers and quadrant 2 is your negative answers. So this is saying, all right, let me put like an arrow here. This is saying cosine of what angle is equal to negative square root of 2 over 2. Well, if my answer has to be in the first two quadrants, then it's the same angle, 135 degrees. So we end up with theta is 135 degrees. So this is one of those cases where the cosine and inverse cosine and cosine cancel each other out. Everything's valid. But remember, that doesn't always work, so you have to be very careful when you're dealing with these inverse functions. All right, so next one is tangent, inverse tangent of 4 pi over 3. So first we start with tangent of 4 pi over 3. Okay, so tangent 4 pi over 3 is a full pi plus an extra third of a pi. So this right here is a third of a pi. Really, it would be more. But anyway, so if you want to figure out what that is, tangent is positive, negative, positive, negative. So my answer is going to be positive. Well, I can go back up to the table that I drew. So tangent of pi over 3 is just square root of 3. So I know the answer to this is going to be a positive square root of 3. Well, the answer that they're asking me, the tangent of what angle is square root of 3? Well, my answer has to be in quadrants 1 and 2. I notice that the angle that they gave us is not in quadrant 1, or sorry, I said 1 and 2. Quadrant 1 and quadrant 4. But the angle they gave us is in quadrant 3. So this is one of those cases where they don't just cancel out and you end up with the same thing. What I need is I need another positive answer that gives me the same thing. Well, since this is positive, then my answer has to be over here. And it has to be the pi over 3 right there. And so theta, in this case, is going to be pi over 3. Because tangent of pi over 3 is positive square root of 3. All right. Now, what if you don't have anything on the inside? If it's just a variable? Then if it's just a variable, then you can assume that the inverse tangent and the tangent would kill each other. So here in this case, if you have just a variable, the answer would just be x. But if you have numbers, you have to make sure that the answer you get is in the range of the inverse. If not, then the number will change. Like this one was tangent, the inside was 4 pi over 3, but my answer ended up being pi over 3. Anyway, let's go to the last page and we'll wrap it up. So when you're solving for this, they're saying find sine of theta. where theta is equal to inverse cosine of 1/2. But that in itself means that cosine of theta is equal to 1/2. Cosine happens to be adjacent over hypotenuse. So I can create a triangle out of this, where my adjacent side is 1, the hypotenuse is 2, and I can use the Pythagorean theorem to figure out, I'm going to call this just side A, to figure out what this is. So 1 squared is 1, plus A squared equals 2 squared, which is 4. Subtract the 1. So A is equal to square root of 3. Since these are lengths, we're dealing with just the positive square root of 3. Okay? So now looking at this, sine of theta. Theta is opposite over hypotenuse. Our sine is opposite over hypotenuse. So opposite is square root of 3. Hypotenuse is 2. And that's your answer. Okay, let's move on to the next one. Let me go ahead and shrink everything. Anyway, so this is cosecant of inverse tangent. So this is cosecant of theta, where theta is equal to inverse tangent of 4/3. So that means that tangent of theta has to be 4/3. So if I draw my triangle, tangent is opposite over adjacent. So opposite over adjacent. Notice this is a 3, 4, 5 triangle. So I can just fill it in. And now I can find cosecant. So cosecant of theta. Cosecant is the opposite of sine. So sine is opposite over hypotenuse. So cosecant is hypotenuse over opposite. So 5/4. So hopefully these aren't too bad. They're actually kind of fun. I like doing this. But basically, if I give you the inverse trig of something and put it on the inside, then you can create a triangle with it. That's the main idea. All right. So keep chugging. Write an expression of sine inverse tangent of x as the equivalent of x only. So this is exactly the same idea, except now it's just with variables. So sine theta, where theta equals inverse tangent of x, which means tangent of theta, tangent of, sorry, yeah. Oh no, I had it right. Tangent of theta is x over 1. So remember that tangent is opposite over adjacent. So if I create my triangle, I have theta right here. Opposite is x. Adjacent is 1. All right. Now there's 2 ways this could have happened, so I want to address both ways. The other way, because the only one that's guaranteed to be positive is the hypotenuse. Another possibility for this would be if they were both negative. Let me move everything over. So there's 2 ways that the answer could have equaled x. It could have been positive x over positive 1, or negative x over negative 1. So if that's the case, that triangle would be the triangle in quadrant 3. Let me try to make it a little better. And so this would be your theta. This would be opposite, it's negative x, negative 1. Okay? Now, regardless of what you do, when you solve it, the hypotenuse is going to be positive. So 1 squared plus x squared equals hypotenuse squared. We call it h for hypotenuse. And so that's just 1 plus x squared equals h squared. I can take the square root. And so that's what's going to go for my diagonal. Square root of 1 plus x squared. All right. Anyway, so now I want to find sine. Sine is opposite over adjacent. Sorry, opposite over hypotenuse. And so my answer here, notice that I go over and I have x. For the right triangle, it can be x over the square root of 1 plus x squared. Or if I look at the other one, it can be negative x over the square root of 1 plus x squared. And so in this case, since there's two answers, I'm going to do plus or minus. All right, so my solution is plus or minus x over 1 plus x squared. So this one was the hardest one, only because, or did I even do it right? Let's see. Inverse tangent. Yeah, x. I'm going to put pause because I could have just screwed everything up. But I tend to do that. All right. I don't know. I just got carried away with things. So here, the answer that you get for theta, I forgot what I had mentioned earlier. Because okay, so I'm going to clear this up, and I'm going to explain where I messed up. Remember that theta has to be between, because it came from inverse tangent, has to be between negative pi over 2 and pi over 2, because that's the range. That means that this solution actually couldn't exist, because that's not within the right range. So here is the axis. And so my answer can only be in quadrant 1 or quadrant 4. And there's nothing in quadrant 4. So that eliminates the negative answer. I had a feeling something was wrong, and I should have trusted my gut. Let me fix this real quick. All right, so because of that, we can actually get rid of the negative solution. I'm sorry. So your answer for this is just this one. See, that range, for knowing your domain and ranges for your trig functions is really important. Maybe I did it on purpose. No, I didn't. I just messed up. All right, so let's do number 7. This time I'll keep the ranges in mind as I do this. Okay, so we're saying secant of theta is equal to what? Where theta is the inverse cosine of 1 over x. Well, this means that cosine of theta is 1 over x. And, so I don't screw up this time, this theta, since we're dealing with cosine, the range has to be between 0 and pi. So this means it can only be in quadrant 1 or quadrant 2. So and cosine is adjacent over hypotenuse. Well, because it's positive, the hypotenuse is always positive. So the only way that this could be positive is if the top is also positive, which means that this has to be in quadrant 1. So the only possibility here for this one is quadrant 1. So adjacent, there's your x, and now we can find this missing side. So here I have 1 squared, which is just 1, plus a squared equals x squared. Subtract the 1. And then take the square root. When you take a square root, a square root cannot distribute over addition or subtraction. That is very illegal. So I get a is equal to just the square root of x squared minus 1. And so that's what goes here. And so now I'm looking for a secant. Well, secant is just the flipped version of cosine. So if cosine is adjacent over hypotenuse, secant is hypotenuse over adjacent. So in this case, hypotenuse is x, adjacent is 1, and so my answer is just x. Kind of anticlimactic, but notice that we didn't use this value that we found on the right, but that's not always the case. If this was sine of inverse cosine, then we would have used it. If it was cosecant, we would have used it. So it's always a good idea to find the extra side of the triangle, because you never know if the function that you're having is, well, you will know, but it's a good habit to get into. Anyway, that's that. Apologies for messing up on number 6, but hopefully I explained it and explained why we eliminated that answer. Anyway, I want y'all to have a good one. Stay safe, and yeah, have a good night.